Today we're going to be talking about linear equations that are given to you in other forms than slope-intercept form. Recall that slope-intercept form, that's when you have something that's given to you as y equals mx plus b, where m is always the number that's attached to x, and b is always the number that's by itself. So for example, in the equation y equals negative 7x plus 10, the slope would be negative 7, and the y-intercept would be the point 0, 10. Another common form, however, is point-slope forms and also standard forms. So today we're going to learn about how to work with these two forms. In short, point-slope form, rather than directly reading off a slope and a y-intercept, you directly read off a slope and some other point on the line. How do you know what that other point on the line is? Well, the number being taken away from x in parentheses is the x-coordinate of the point, and then the number being taken away from y in not in parentheses because nothing's being multiplied, but the number being taken away from y is the y-coordinate of the point. So in this example, for example, we've got two different parts that correspond to the point. For x minus 5, that means that the point will be at 5, because we took away 5, negative 2, because if it says plus 2, that means we must have taken away a negative 2. In short, you're going to be looking in where whatever's being added or subtracted from x, that's the number that's your x-coordinate, and you will always flip the sign of whatever's in front of it. So if it says minus, that x-coordinate was a positive. If it says plus, that x-coordinate was a negative. And then similarly on the y, you're going to be looking at what's being taken away from the y. And then you're going to take whatever is that sign right in front of that number, and you're going to flip the sign on that. So if it says plus 2, it must have been a negative 2 that was taken away. If it says minus 2, that must have been a positive 2 taken away. And then the slope, that part's going to look the most familiar from your slope-intercept form. That's always the number that's being multiplied out front of the parentheses. So in particular here, your slope would be negative 2/3. So it's still the number being multiplied by your x's. It's just that rather than there being a single x, there's going to be this entire x plus or minus something in parentheses. The final type of form is standard form. And even though it's called standard form, it's actually kind of the least nice to work with. Basically, if you're going to work with standard form, you have two choices. You either need to convert it to look like slope-intercept form, or you need to plug and chug some points. Both of which are concepts we've sort of gone over before. So for example, if you had 5x minus 2y is 10, you could go ahead and solve for y using your knowledge of literal equations. You'd first take away 5x from both sides because your goal is to get that y by itself. 5x minus 5x gets you 0. Negative 2y is equal to negative 5x plus 10. You're allowed to write it in the opposite order because 5 plus 2 is the same thing as 2 plus 5. And then as the last step, you would divide all three terms by negative 2 because y is being currently divided by negative 2 to get you that the equivalent equation to this would be y is equal to positive 5 halves x, because negative divided by negative is a positive, minus 5, since a positive divided by a negative is a negative. And then you could plot it from that form. So these would be equivalent. Alternatively, if you don't want to convert it, there are also other methods to approach that as well. So without further ado, let's go ahead and dive a little bit deeper into each of these techniques now that we have a little bit of an overview. So in particular, you can always graph equations by just converting them to their expected slope-intercept form. How are you going to do that? Well, in order to convert, you need to solve for y. So that's where knowledge of literal equations can be really, really helpful. Then you will want to go ahead and plot this sort of the regular way you always plot from y equals mx plus b. You're going to start your y-intercept and then move according to your slope. So in particular, let's say you want to solve this next equation for y. Go ahead and pause your video and try to solve for y yourself, and then we can compare answers. So in particular, we've got to move this negative 10x to the other side, and we're going to undo subtracting 10x by adding 10x on both sides. Negative 10 plus 10 makes 0. I'm left with 5y is equal to positive 10x minus 15. Then as a last step, I've got to divide each and every term by 5 in order to undo multiplying by 5. So I'll be left with y equals 10 divided by 5 is 2. Negative 15 divided by 5 is negative 3. Now from here, I can directly identify my slope and my y-intercept. In particular, my slope is going to be the number being multiplied by x, in this case 2. So my slope would be here 2, which is secretly 2 over 1. And then our y-intercept is going to be the number being added or subtracted by itself, because if I plugged in 0 for x, that's all I would be left with. So in this case, my y-intercept would be at the point 0, negative 3, 0, negative 3. Because that minus is indeed attached to that y-intercept. So that's exactly how I'd plot it. I'd start at 0, negative 3, then I would move up to right 1, or equivalently down to left 1. And then I would want to double check with my line. If I were to walk on top of the line from left to right, would I be going uphill? Yes, I would be, so I know I did it correctly. Let's take a look at another example. So this example you can recognize is going to be in point slope form, because in particular there's a number being added or subtracted from the y here on the left, and the x is joined with another number being added and subtracted, or subtracted in parentheses here. So we want to keep in mind that the general form for point slope form is y minus y1 is equal to slope times x minus x1. So we want to note what's sort of in each position. For the slope position, it is the slope of 1/2 here. So we can go ahead and note that our slope is equal to 1/2. For your point, you can go ahead and note that that is your x1, y1 here. So x1 being that we subtracted a negative 2, y1 being that we subtracted 8. So that is our point. Again, you are flipping the sign on both of those. We must have minused a positive 8 on the y, minus a negative 2 on the x. Alternatively, you can also just convert this to slope-intercept form as well. And what would that look like? Well, you would distribute the 1/2 to both terms. 1/2 times x is 1/2 x. 1/2 times 2 is 1 equals y minus 8, and then we would go ahead and add the 8 to both sides in order to get y by itself. So then we'd have y equals 1/2 x plus 9 as that final equation. So you can plot this from either of these pieces of information. Now what I would also note is I really should have given you a graph that was labeled differently here, so I'm going to go ahead and relabel it as counting by 2s instead of counting by 1s. Because if you'll notice, with the graph sort of being as is, there is no room either for the point -2, 8 or for the point 0, 9. So I think it will be helpful to just go ahead and presume that these grid lines are counting by 2s instead. So if that was the case, then there's two different ways you could plot it. You could start the point -2, 8, and then move according to the slope. So since this is counting by 2s, moving down 1 would be moving half a tick mark. To the left 2 would be moving 1 whole tick mark, or you could be moving up 1, which would be moving half a tick mark, to the right 2, which would be moving a full tick mark. And then if you notice, that also exactly crossed the point 0, 9, which we had also expected should have been our y-intercept from our slope-intercept form. So they really do play with one another. You can graph from either form. You just need to pick a strategy and go with it. And then if you want to be extra careful, you always could graph from point slope form. Double check that when you convert him to slope-intercept form that he has the y-intercept that you're expecting. For standard form, there are kind of two different options as well on how to graph it. So you can actually formally convert him to slope-intercept form and then graph that like we did earlier. Or you can also just plug and chug some points. If you're going to plug and chug some points, it is recommended that you go ahead and find the x and y intercept, because that's actually the nicest thing to find from this form. That's usually the main reason why people might choose to work with this form directly. So if you have 6x minus 4y is equal to negative 12, and let's say you want to find the y-intercepts, or y-intercept I should say, and the x-intercept. Go ahead and pause your video and try to find this yourself, and then we'll go over how to find it together. So if you're going to find a y-intercept, that means you want to plug in x is 0, because that's where he crosses the y-axis, so he hasn't moved left or right. If I plug in x is 0, 6 times 0 is just 0, and then my last step would be to undo multiplying by negative 4 by dividing both sides by negative 4. Negative 4 divided by negative 4 is 1. And I'm left with y is positive 3, since negative 12 divided by negative 4 is going to give me a positive. So we know we have a point at 0, 3. For the x-intercept, what I'm going to do is a similar sort of process, but I'm going to plug in y is 0 instead. So I'll have 6x minus 4 times 0 is equal to negative 12. Then anything times 0 is just 0, and as a last step I would need to divide both sides by 6. 6 divided by 6 is 1, and I'm left with x is equal to negative 2. So negative 2, 0 would be the point I just found, plugging in the x for x and plugging in that y is 0 when I initially plugged in to find these points is y. And then when I connect them, that is our nice beautiful line. You can, of course, graph directly from point-slope form just as we went over earlier. So if you're going to do that, you want to identify the slope and identify the point. You want to start your point and then move according to the slope. So in particular here, it looks like our given point is negative 9, since if it says x plus 9, that means we might have subtracted a negative, comma, negative 3, because if it says x plus 3, we must have subtracted a negative. And our slope is positive 7/2, because that is the number that is being multiplied by the x term in parentheses. So in order to plot this, we're going to start at our point, which in this case is negative 9, 1, 2, 3, negative 3, and then move according to our slope. So going up 1, 2, 3, 4, 5, 6, 7, right 1, 2, or equivalently down 7, 1, 2, 3, 4, 5, 6, 7, left 2, 1, 2. And then we can connect these guys in a nice beautiful straight line. And this is a good example where had I insisted on rearranging this into slope-intercept form, that intercept would be off the page. We can also work the other way around. So let's say I wanted to find an equation that has a particular slope that goes through a particular point. Well, the fastest way to do that is actually to go ahead and plug that into point-slope form. So recall that's y minus y1 is the slope times x minus x1. And this equation also, keep in mind that point-slope form is just really a rearranging of the formula for slope. That's really what we did there, because if we were to divide both sides by parentheses x minus x1, we'd be left with y minus y1 over x minus x1 is equal to slope, which is a formula you already know. So it's not just a magical formula, it is something that you've seen a lot. But in particular, if we were going to then plug this in, we would have y minus, the y coordinate is negative 5 for my y1, so that becomes minus and negative 5 becomes plus positive 5, equals my slope is negative 2, parentheses x minus the x coordinate is 4. And that would be my final beautiful equation. Then if I want to plot it, I want to start at 4, negative 5. So going right 4, down 5, and then I want to move according to the slope. So I can move down 2, right 1, or equivalently up to left 1. The key for a negative slope is that if you move positively one way, you need to move negatively the other way. And then I want to double check myself. If I were to walk on top of the line left to right, I would be going downhill, so I know I graphed him correctly. You can also use point slope form to just write any equation that goes through any 2 points, and you don't have to do the step of solving for the y-intercept like you had to do whenever you were always writing equations in slope-intercept form. So in particular, let's say you want to find the equation of a line that goes through these 2 points. Well, first I would just sort of arbitrarily label one x1, y1, the other one x2, y2. I would also maybe sort of sketch off to the side what I approximately think that this guy is going to look like. Doesn't need to be super to scale, but it will sort of let me know that as a sanity check, I'm expecting this guy to have a positive slope, and for him probably to have a negative y-intercept somewhere if I insisted on sort of converting him to slope-intercept form. But as is, I'm just going to solve for the slope from here. So we have our slope is equal to y2 minus y1 over x2 minus x1. It can sometimes be helpful to put that minus and negative in parentheses. Keep in mind that minusing a negative is the same thing as adding a positive. So negative 3 plus positive 5 gets us 2. 2 plus positive 6 gets us 8. 2 over 8, both of those are able to be divisible by 2, leaves us with 1/4. So here, if we're then going to put that in the final form, we would have y minus y1, so plus 5, because minus negative 5 turns to adding a positive, equals 1/4 parentheses x minus x1 minus negative turns to adding a positive. And that is your final beautiful equation. You could have equivalently chosen to use the other point instead, and it would still work. So y minus y1, so minus a negative 3 and equals plus 3, equals 1/4 parentheses x minus x1, x minus 2. Both of these actually will simplify the same way. It's left as an exercise to you that if you want to kind of prove off to the side that both of these will simplify to the same slope-intercept form, that's a good mathematical exercise. So go ahead and try these next 2 problems yourself and then circle back to compare to see if we get the same answers. So for the first one, they're wanting you to rearrange this into slope-intercept form, which means I've got to solve for y. How am I going to do that? Well, first things first, I got to move the 7x to the other side. So I'm going to undo positive 7x by subtracting 7x on both sides. That leaves me with negative 4y is equal to negative 7x plus 12. And as a last step, I still need to get y by itself, so I'm going to divide all 3 terms by negative 4. Negative 4 divided by negative 4 is 1. Negative 7 divided by negative 4 becomes positive 7/4. Positive 12 divided by negative 4 gives us negative 3. And that is my final equation. If I were to plot it, I would plot it having the y-intercept at 0, negative 3, and then I would move according to my slope, which would be rising 7, running 4, and you'd want to be in the positive direction, so you'd want to make sure that it looks like you're going uphill from left to right on top of the line. But here they just wanted us to convert, so that's all we did. For the next one, if you're going to graph this line, in particular, you should recognize what's the point they want us to plot. Well, we've got minus 6 plus 2. That's corresponding to our point in question. So our point is positive 6, because I must have subtracted a positive 6, comma negative 2, because I must have subtracted a negative 2 if it says plus 2. That's my point. And then my slope is negative 2/3, because that's the number being multiplied out in front of the parenthesis. So if I'm going to plot that, I'm going to start at 6, comma negative 2, and then move according to the slope. So I'll be going up 2, left 3, or equivalently down 2, right 1, 2, 3. Either of those will give me my nice, beautiful negative slope, and I want to double check as a sanity check that if I were to walk on top of the line going left to right, am I going downhill? Is this guy decreasing? He is. I'm good. I must have done it correctly. Go ahead and pause your video and see if you can write this next one yourself. So if you want to find the equation of the line that goes through these 2 points, first things first, you're still going to have to actually find the slope no matter what form you write it in. So I'm going to go ahead and arbitrarily label an x1, y1, an x2, y2. So y2 is 1, y1 is negative 5, x2 is 3, x1 is 1. 1 minus negative 5, keep in mind that's the same thing as plus a positive 5. So that's going to get me 6 over 3 minus 1 is 2. 6 divided by 2 simplifies to 3. So I'll have y minus a negative 5 becomes plus 5 is equal to 3 parentheses x minus 1. If I were to plug in x1, y1, or equivalently, I could write y minus 1 is equal to 3 parentheses x minus 3 for if I plugged in x2, y2 instead. Either of those are fine. In either of those, I plugged into the form y minus y1 is equal to my slope x minus x1. I might want to also do a little quick sketch off to the side to make sure that this looks approximately correct. That it looks like it does indeed have a positive slope, which is what I found. That's relatively steep. So it looks like our equations are approximately correct. I could also formally solve for the y-intercept on both of these equations, which is an exercise worth trying if you want. I believe it works out to be negative 8, but either way, that's enough information to plot. I'm good to go. Let's go ahead and kind of do one more that sort of wraps through everything. So again, if you're given 2 points, what you want to do is find the slope first no matter what. And I'm going to go a little bit out of order. I'm also going to plot them so that I sort of have a sanity check on what that slope should work out to be, even if I am ultimately finding that slope by plugging into the equation for slope. So it's looking like this should be a negative slope that's not incredibly steep or incredibly shallow. It's sort of somewhere in between, although that part's a little bit subjective, I'll totally admit. So if I'm going to find the slope, I do want to label one of these x1, y1. I want to label the other one x2, y2. And then I want to find my slope by plugging into the slope formula. So first my change in y over change in x. Change in y, that would be negative 4 minus 2. Change in x, that'll be negative 2 minus a negative 8. Negative 4 minus 2 gets us negative 6. 2 minus negative 8, that's the same thing as 2 plus positive 8. That will give us positive 6. Negative 6 divided by 6 is going to simplify to negative 1, which does look approximately like what we have on our graph. We just didn't graph it super carefully. Then if we want point slope form, well, our point, we can pick one of these two. Let's say we want to roll with the point over here of negative 8 comma 2, although we also could equivalently roll with negative 2 comma negative 4. Either way, if we want to plug that into point slope form and that slope is negative 1, we're going to have y minus 2 is equal to negative 1x minus a negative 8 if we're going to plug in the first point. Minus a negative 8 would be most commonly written as plus positive 8. And then if you want to convert that into slope-intercept form, what you would do is distribute the negative 1 to both of those terms. You have y minus 2 is equal to negative 1 times x gives us negative x. Negative 1 times 8 gets us negative 8. And as a last step to get y by itself, you would have to add 2 to both sides. So then you end up with y is equal to negative x minus 6 as your final answer there. Equivalently, what you could have done is you could have plugged in the other point instead, and you should have gotten the same result. So if we plugged in the other point instead, we'd have y plus 4, because minus and negative 4 ends up adding 4. And then you would have negative 1 parentheses x plus 2, since subtracting a negative 2 becomes adding 2. And then again, to convert, you would still distribute. Negative 1 times x gets you negative x. Negative 1 times 2 it gets you minus 2. And then if you were to still do one more step to get y by itself, subtract 4, you would still equivalently get y equals negative x minus 6. And the fact that we got the same answer 2 different ways tells me that we did the equation correctly. So feel free to try to get more comfortable of working with point slope form more directly in particular. It's a good skill to have. For the standard form, which remember standard form are the guys who look like this, feel free to either convert him to slope-intercept form or just plug and chug some points like we did here, and in particular those intercepts are usually a nice set of points to try to plug and chug.